Welcome to Fleaux University. Today we are covering proper solar panel array sizing and battery autonomy. First up, we want to talk about voltage versus current. Usually in the arena that we operate in on location and in the field, we're dealing with DC voltage and current scenarios, or VDC is the way that we generally refer to it. And usually we're dealing with a 12 volt DC voltage, and that's what you're going to generally see when you connect to your equipment and you're reading that voltage parameter. And then the next thing is the current demand or the current draw, and usually for the arena that we operate in the field, that's going to be in a milliamp value. Next up, we're going to take a look outside. We're going to look at a solar array and actually show you how we size that array, both quantifying voltage and the amount of current output coming out of the array. To properly measure solar panel voltage output, again confirming that your leads are in the proper receptacles in your multimeter, switch your multimeter to voltage DC, which is the long straight line with 3 dashes underneath. Place the negative lead of the multimeter to the negative or black lead of the solar panel, and the positive lead of the multimeter to the red or the positive lead of the solar panel, and read the value output on the multimeter itself. As you can see, the voltage is 21.57 volts for this solar panel, which is well within manufacturer specifications. Connecting the leads of the multimeter in the same fashion as it was for voltage to the solar panel itself, configure your multimeter to measure current, dial to the current measurement parameter of the multimeter, and therefore you can see that this solar panel is registering 322 milliamps. Once you have your multimeter set up appropriately with your leads in the proper receptacles, you want to switch it on to, as we spoke about before, voltage DC, which is the solid line above 3 dashes. And at that point, it's pretty straightforward. You want to connect to the negative load and the positive load of your battery and observe the voltage readout on your multimeter, and you'll see that it is acceptable at this point. Next up is checking the current demand from the entire operating system. To do that, you will adjust your multimeter to the amp and milliamp setting. You'll then take your positive lead and connect it to the positive load of the battery, and then in series, you will connect your negative lead of your multimeter in line, and you'll see that it will then demonstrate the amount of current that's being demanded from the battery. This is a piece of software that was developed as a joint effort between Fleaux Services and Fea, and it can prove very useful and helpful in determining the appropriate solar array size as well as battery autonomy parameters for your system. It's very easy to use with very few inputs that can mean a great deal to battery and solar longevity out in the field. The first input is very simply the amount of current demand that we demonstrated earlier. As you can see, as you make these changes, it properly sizes not only the solar panel for different cases and different scenarios of ambient sunlight and temperature, but also structures your system to give you the appropriate days of autonomy needed to keep your system up and running. Thank you for attending Fleaux University. If you have any questions or comments, please feel free to contact us at www.fleaux.com.